This is section 8.6, solving equations with radicals. So we're finally getting to where we're putting everything we know into use. Kind of like when we were solving equations with rational expressions and we had to check every answer in the denominator to make sure it wasn't a false answer, we have to do the same thing here. But this time we have to do a complete check. We cannot just look at it, check a single part of it, and make sure it makes sense. It is likely that we will get false answers, and those are also called extraneous roots. And if there are real correct answers, we will get them in this process. There's no shortcut. We have to do a complete check. Now, the basic idea of how we solve these is fairly easy. What you want to do first is you want to get a radical alone. There are problems that have more than one radical in them, okay? So the thing is, we've just got to get one radical by itself, okay? So we have that here. Once you have one of the square roots by itself, we are going to square both sides. Now, this is the step that can introduce false answers, okay? But it is necessary. Remember that when we square a square root, we get what's underneath. So this is x plus 1. This is the whole idea, is that when we square both sides, we can get rid of the radical. And this is equal to 7 squared is 49. Now we solve this for x by subtracting 1 from each side, and we get that x is equal to 48. Now this is our potential answer. We need to take this and plug it back into the original before you ever square it. So this would be the square root of 48 plus 1, and we hope that that equals 7. That is the square root of 49 is equal to 7, and you can see that that's true. As soon as you recognize that it's true, you can stop, or as soon as you recognize that it's false, you can also stop. But if you keep going, you'll get 7 equals 7. Okay, so since this answer checked out, it is the answer to the equation. Okay, let's try the square root of 4x plus 3 plus 1. Okay, notice how important it is that this plus 1 does not look like it's underneath the radical. When you're writing something like this, make sure your radical bar goes far enough, but not too far. A lot of people put a little mark down like that at the end of it, just so that it can be very clear what's underneath the radical and what's not. That's up to you. Our first step is to get the radical alone, or a radical alone. So I need to subtract 1 from each side. That gives me the square root of 4x plus 3 is equal to negative 1. Now that the radical is by itself, let's square both sides. When you square a square root, you get the radicand, so I get 4x plus 3 is equal to negative 1 inside parentheses squared is 1. Now let's get x by itself. Let's subtract 3 from both sides. That gives me 4x is equal to negative 2. Divide both sides by a 4. And I get that x is equal to negative 1/2. Okay, so this is our potential answer. Let's take it and plug it back in up here. I would have the square root of 4 times negative 1/2 plus 3. Radical bar goes over there and no further. Plus 1, and we hope this equals 0. Okay. Well, a positive times a negative is going to be negative. Half of 4 is 2. So I have negative 2 plus 3 under the radical. So this is the square root of 1 plus 1 equals 0. The square root of 1 is 1. 1 plus 1 equals 0, or 2 equals 0. You can see that that's not true. This was my only potential answer, and it did not work. I have to throw it away. So your overall answer is no solution. There's no number we can plug in here that's going to make this thing work. There is no solution to this. Okay, so let's try the square root of 5z plus 1 minus 11. We again need a radical by itself, so I'm going to add 11 to both sides. That gives me the square root of 5z plus 1 is equal to 11. Now let's square both sides. And that gives me 5z plus 1 is equal to 121. Get the z by itself, I'm going to subtract 1 from each side. That's 5z is equal to 120. Divide both sides by a 5, and we end up with z equal to 24. Okay, so let's take this 24 and plug it in here. It's going to be the square root of 5 times 24 plus 1 and of radical bar minus 11 equals 0. So I have the square root of 5 times 24 is 120 plus 1 minus 11 equals 0. So this is the square root of 121 minus 11 equals 0, which gives me 11 minus 11 equals 0, which is true. So this is your answer. Okay. All right, so let's try our first problem here with more than one radical. Okay, remember, you just want to get a radical by itself. It does not matter which one. Now, it just so happens that we end up with both radicals being alone. Okay, as soon as you have at least one of them by itself, you square both sides. Okay, so when you square a radical, you get what's underneath. So that's 9a minus 4 is equal to 8a plus 1. We want to get our a's by themselves, so I'm going to subtract 8a from both sides, giving me a minus 4 is equal to 1. Add 4 to both sides, and I get a is equal to 5. Okay, now let's check this. That will be the square root of 9 times 5 minus 4 equal to the square root of 8 times 5 plus 1. So this is the square root of 45 minus 4 is equal to the square root of 40 plus 1, which gives me the square root of 41 equal to the square root of 41. I don't have to know what the square root of 41 is. I don't even have to try to simplify this anymore. I'm just hoping that I end up with the same thing on both sides. And I do, so this is my answer. Okay, so let's solve this one. I have k is equal to the square root of k squared plus 4k minus 20. We want to have one of our radicals by itself, and we do here. So we square both sides. So this gives me k squared is equal to, when I square this side, I get what's underneath, k squared plus 4k minus 20. Okay. Now I see I have a square here. And I generally think that when I have a square, I'm going to have to factor and solve, so I need to get a 0. But when I go and I subtract k squared from both sides, they cancel. So I end up with 0 is equal to 4k minus 20. So that means I have an easier problem to solve here. I'm going to add 20 to both sides. So I have 20 is equal to 4k. Let's divide both sides by a 4. And I get 5 is equal to k. Okay, so let's take this and plug it back in and see if we get if it checks out. I will have 5 is equal to the square root of 5 squared plus 4 times 5 minus 20. So that's 5 is equal to the square root of 25 plus 20 minus 20. And of course, those cancel. So I have 5 is equal to the square root of 25, which is, of course, true. 5 equals 5. So this is a good answer.